So here we're going to look at drawing straight line graphs where you can use the Y-Intercept method, so you won't actually have to use a table. Now either method will work for you, so don't stress out about having to know both of them. The one that works for you will work for you, but this method will become very useful for you as you go on with your maths. So the first thing that we need to look at is just kind of understanding in the format of y equals mx plus c what that means, because this is the format how you'll mostly see the equations written. So y equals mx plus c, remember there's an invisible time sign between the m and the x because two letters written together have an invisible time sign. So that's really y is equal to m times x plus c. And this m represents something special. That is the gradient of the line. And the c is the y-intercept. Or I sometimes just abbreviate that as the y-int. So we've talked about these briefly before. The gradient has to do with the steepness of the line, and that can be referred to or found using the rise over the run as a rule to figure out what the gradient is. So how far up you have to go and how far over you have to go to get between any 2 points on the line. You can write it as a fraction, sometimes it's a whole number. And the y-intercept, again, is where the line crosses the y-axis. So if we take a look at these two colorful pictures, I want to ask, what do these graphs have in common? So in the first picture, we see they kind of make this nice circular pattern for us, if you want to imagine that. But what do all of these lines have in common? And thinking specifically, would it be their gradient or their y-intercept? Now again, the gradient is kind of like the steepness. So in this first graph, we notice there are all different sorts of steepnesses, but they all do what? They all cross through the y-axis at the same point. So here, they all have the same y-intercept. So all four of those lines, in fact, four of those lines have the same y-intercept. They all cross the y-axis at the exact same point. So that's what they share in common, but they have all different steepnesses, so they are going to have different gradients. For the second picture, what do we notice about these four lines now? They have a different y-intercept, each of them cross the y-axis at a different point, but the thing that they now share in common is that they all have the same gradient. I can see that visually by looking at the graph because they all run like parallel railroad tracks. They're never going to cross each other, they're parallel, and they all have the exact same steepness to them. So in this case, they're all going to have the identical gradient of each other, but with different y-intercepts. So the first thing to be able to do for plotting these equations using the y-intercept method is to be able to identify from the rule what's your y-intercept and what's your gradient. And the first thing you always want to look at is the y-intercept. And again, that's the plus c part of this equation. Sometimes it's a minus, but it's the number added on without the x, and that's another thing to remember that's actually really important. So the y-int is number without x in rule, because it doesn't always have to be written in the exact same order, which can get tricky. So if the y-intercept is the number without the x, let's look at this first example. Y is equal to 5 over 6 times x plus 7. So that's going to be my y-intercept, the plus 7. So we would say 7. The y-intercept for the next equation, y is equal to negative 1 over 3 times x plus 4. In that case, it's going to be 4. And for the last one, y is equal to 2 times x minus 3. The y-intercept there is going to be, in fact, the negative 3, because we see it's minus 3. Now your gradient is always the number with the x. I'll just highlight that in for each of these. And put a little note here. So the gradient always with x. Okay. So again, with these examples, the gradient on the first one is 5/6. You can leave it as a fraction, that's fantastic. -1/3, and in this case 2. Now we have a little trick that can work for us, and I'll show you later on how that is actually more helpful, but just so you're aware of it, if the gradient's a whole number like 2 or 4 or 7 or -3, and it's not a fraction, don't be afraid to write it as a fraction by putting it over 1, and that can help us plot it a little bit easier. So keep that in your mind. You can always put it over 1. Okay. So the pattern that we have to go through to actually plot these things is the first thing that we're going to do is mark out the y-intercept with a point. So if I look at this first equation, my y-intercept is +3. So that means at y is equal to 3, the line is going to go through the y-axis. So I'll go up to y equals 3, and I'll put in a point. Now from there, because that's going to be my start point, I'm going to use the gradient to count out the rise over run to the next point and draw it on. So my y-intercept always has to be my starting point. We have to make that the start, and now I need to think about what my gradient's telling me. My gradient here is saying a rise of 1 over a run of 2, 1/2. So what that means is I need to go from my y-intercept, I have to go up 1, and then over 2, 1, 2. And I can put in the next point. And again, from that point, I can do another one, up 1 over 2. In between every single one of those points, I'll follow the same pattern, up 1 over 2. And once you've got a series of those going together, it's quite clear to see that you've got the straight line appearing here. So now you can draw the straight line through the points. Now you need to make sure you extend it through the whole graph with arrows on the ends. It's not just across those. So what I mean is I wouldn't just go like this and call my graph done. I have to continue it all the way out with arrows on the ends. So if that's equation A, that's the graph for A. So again, starting at the y-intercept of 3, noticing that my gradient says 1/2, so I'm going to go up 1/2 and put in my next point. Once you've got at least 2 points, you can connect the line, but feel free to put on more using the same steps in the gradient, up 1/2. Okay. Looking at the next one. Let's call this B. Think about what your first step is. Again, we have to mark the y-intercept with a point. That's always going to be your starting point. So find the y-intercept here. It says +2, so that means we'd go up 2 and put in our first point. From that y-intercept, use the gradient to count out the rise over run to your next point and draw it in. So my gradient here is actually saying the rise of -3 over a run of 4. What do you think that means, the rise of -3? It's basically saying we need to go down instead of up. So if your gradient is negative, you're going to go down instead of up. So a negative gradient is down. So from here, I'm going to go, from my y-intercept, I'm going to go down 3, because it's -3, 1, 2, 3, and then over 4, because it's a run of 4, 1, 2, 3, 4. So again, I've gone down 1, 2, 3 steps from my y-intercept, and I go over 1, 2, 3, 4. Now that I've got my 2 points, I can just go straight to drawing on the line. Oops. Again, it can be tricky on my tablet, sorry. But you get a nice, hopefully prettier than that, straight line extended through with arrows on the ends. For the last one, y is equal to 4x minus 3. So same steps that we've had. Need to find our starting point, which is the y-intercept. So my y-intercept here is going to be negative 3. That's the number without the x. So negative 3, which means I need to go down 3 to put in my first point. That's my y-intercept for this equation. The next thing is to use my gradient. But here I'm noticing that my gradient is just rise of 4. And it's not a run of nothing. That doesn't mean just go up 4, up 4, up 4. That was the hint that I gave you earlier, which is that if you've got a whole number, you can think about making it a fraction by putting it over 1. So that actually becomes rise of 4 over run of 1. So here I'm going to go up 4, 1, 2, 3, 4, over 1. And if I want another point, again I can go up 4, 1, 2, 3, 4, over 1. And once you've got at least those 2 points put in, from there, using a ruler, you can draw on your straight line. The arrows on the ends. So, tricks for you. You always got to start with your y-intercept. You need to find it and start there. You never start counting from anywhere else. So find your y-intercept, put your pen down there, draw on your first point, and then use your gradient from that point to count out the rise over run to the next point on the line. Tricks for you to remember: if it's negative gradient, you're going to go down instead of up. And if it's a number like 4, you can draw that as 4 over 1. Because again, 4 divided by 1 is still 4. You haven't changed the number, but now it gives you a rise over a run, something you can go with. And one more trick for you, just to be aware of it. Make up another equation here. I could do something mean to you like this, and give you an equation like 2 plus negative x. So let's think about this one. What's my y-intercept? Remember, I told you the y-intercept is the number without the x. So in this case, it's not just the last thing, which is an x here. It's actually the number in here without the x, which is a plus 2. Meaning I need to go up to plus 2 to put down my first point. Now my gradient is also tricky here, because the gradient's always the number with the x, and if you look here, you don't see a number. But watch out for your invisible numbers, especially your invisible ones. This equation really says y is equal to 2 plus negative 1x. And if there's no number in front of the letter, you can draw in an invisible 1. And once you've got that, the next trick to remember is, well, negative 1, that's not a fraction for me yet, so I can still write that as negative 1 over 1. Now, I've got my y-intercept of 2, and I know my gradient is negative 1 over 1. So my rise is negative 1, my run is 1, and you can think about that as your fall of 1. You have to go down 1, and then over 1, and down 1, and over 1, and down 1, and over 1, and down 1, and over 1. And going up, up 1, over 1, up 1, over 1, up 1, over 1. As a trick, if you want, you can just flip the signs and go the opposite direction. So if you're going down 1 and to the right 1, you can go up 1 and to the left 1. That's kind of advanced. So, once you've got your points on there, try your best to draw a straight line. Again, my tablet makes this very difficult, so hopefully yours look better than mine. Try to extend it out, and make sure you get your arrows on the ends. So watch out for the order. It's not always the end number that's the y-intercept, it's the number without the x. The gradient, you can always turn into a fraction by putting it over 1. If there's no number there, don't forget your invisible ones. And that should just about cover you guys. Give a go with trying to plot some more of those lines.